Alright, 10-2 transformations of quadratic functions. Alright, today's assignment goes off these notes, and also tomorrow's assignment is just a continuation from these notes. So these notes will be for 2 days worth of assignments. Alright, and actually we're going to flip this over and we're going to start on the back of the notes. Alright, so we have transformations of graphs of a quadratic, and we have an equation. It goes g of x equals a times the quantity of x minus h squared plus k. Now we've had h and k before. We had them when we had absolute value. So we're bringing them back, and now we're just bringing them back for quadratic functions. We've had these before though, okay? We've had these before. We've had movement before. So transformation. So first we're going to talk about translation, which is just a slide. So we're sliding our graph. All right, so it's going to stay looking the exact same. It's just going to slide either right, left, or up, down, or who knows, maybe both. Okay, so let's first talk about our h. All right, so an h is inside the parentheses with the x, so it directly affects the x. And we notice we have a negative sign in front of that h, so it means opposite of h. So that's going to come in to play here in a hot minute, okay? So just keep that in the back of your mind. So when h is greater than 0, translate units right. And when h is less than 0, the absolute value, units left. Okay, now the great thing about this is we aren't going to be asking you, and you won't be asked to determine this from graphs themselves. You may have a graph, but you will also have an equation. And so you will be looking for the equation, all right? And you'll be looking for these items in the equation itself, okay? So h is inside the parentheses, so it affects the x. All right, so with the x, or your x-axis, so we're talking right, left. All right, so we're going left, right, left, right. All right, but because it's the opposite of, because of that negative sign, we're going to think about doing the opposite of whatever it is we would have a natural inclination to do, okay? So if you see a positive h, then you're going to move left. Now why? Well, a negative times a negative is a positive, so technically it would be a negative h, all right? It would be a negative number. And then if you see a negative, you're going to move right. Because a negative times a positive is a negative. So if you see a negative, the negative h times the positive number, all right, your number is positive. So positive numbers go to the right, negatives go to the left. So you got to think about the opposite of. All right, so there's our h's. Next up, I'm going to deal with k's. Okay, I'm going to deal with our k. Our k is outside of the parentheses, and you'll notice there's a sign in front of it. Okay. Now, sometimes this may be in front of the x, but there'll be a sign between them to signify that it's a k and not an a or a b. Okay. So there's a sign involved with this k, and this is a vertical translation, so it is outside my parentheses, so it is vertical. It affects the y, so it goes up, down. Okay. And if k implies it's positive, if k is greater than 0, we're going up. If k is less than 0, we are going down. Okay, so k tells you you're up, down. And remember, there's plus sign, and if there's a sign behind it, plus or minus, it is affecting the y, okay, not our x. All right, so those are our horizontal and vertical translations. Okay, now let's get to the A's. All right, let's get to our A's. So our A's could okay, the A. Now currently our A is telling us if we are filling our cup or emptying our cup, all right? So if A is greater than 0, it opens up. If A is less than 0, it opens down, okay? So if there is a change, you are just reflecting it over the x-axis. And since it is affecting the x, all right, so it would flip. Okay, so if it starts positive and then it's negative, then it flips. It reflects over the x-axis. But what you'll see more often is for dilation, okay? Dilation. Now, if the absolute value of A is greater than 1, this is a stretch vertically, okay? A is outside of my parentheses, so it affects the y, so we are vertical, okay? Now, if the absolute value of A is a fraction less than 1, okay, then it's a compress vertically. Again, it is outside the parentheses with the x, so therefore it is vertical, and that means it affects the y, okay? So let me see, if A is greater than 1, all right, or the absolute value of A is greater than 1, then it is a vertical stretch. Okay, if the absolute value of A, well, if that is a fraction that is less than 1, it is a vertical compress. And again, the A is outside the parentheses, so it is not affecting the x, it's affecting the y, hence the vertical. Okay? Now there is one other form of this equation you may see. So we're going to write that. It has a b in it, okay? So there's one other form. So you could see f of x equals a times the quantity of bx, notice the b is inside parentheses and it's multiplied by x, minus h squared plus k. So your k, your h, your a, same features, but what we have here that we haven't covered is what happens when we have a b. Notice it's inside parentheses, it is multiplied only by the x, all right? Now, since it affects the x, we're talking about horizontal stretch or compress, okay? Because it is multiplying your x. So we're stretching or compressing. So horizontal stretch or horizontal compress. Okay? But the rules are the opposite for when we are vertical. Okay, so we have opposite rules. And we are going to write those here in a minute. So for our horizontal stretch, okay, the rule is, all right, B is in between 0 and 1, so that means it's a fraction less than 1 to be a horizontal stretch. Or B is greater than 1 to be a horizontal compress. All right, so the rules are opposites. All right, so again, we are not going to have to graph these. We aren't even going to have to really do these strictly from a graph. We'll be given equations. So let's go on the front, okay? Now, the most basic parent function is f of x equals x squared, all right? And then all of these are based off of this parent function. So we are going to draw our parabola. We know it's quadratic because the highest power is square. So remember, squaring is based off the actual two-dimensional square with 4 sides, hence the quadratics. Okay, so we can also say x squared plus 0. Okay, it means the exact same thing. And the 0 does absolutely nothing for our graph. We're going to make a little table, or some of my students like to call it a T-chart, for x and f of x, okay, or y. So we get to pick the x's. All right, so the standard approach for when we pick the x's are some simple small numbers, then the positive versions of this, okay? And then we just put what x stands for. We have 5 different quantities for x. We're going to put each of them in our little equation and find out what our outputs are. So -2 squared is 4. -1 squared is 1. 0 squared is 0, and 1 squared is 1, and 2 squared is 4. Notice our y's get smaller, and then they get bigger, and we seem to have a vertex of 0, 0. Let's graph these. So -2, 4. -2, 1, 2, 3, 4. -1, 1. 0, 0. 1, 1, and 2, 4. It looks like our parabola, right? So we can draw in our parabola, okay? Just like that. All right, so that's a parabola of the bare bones basic parent function. And this is our vertex. All right. Now, we have, remember our equation, f of x equals a times the quantity of bx minus h squared plus k. So the location of the number tells us what we're doing with it, okay? So you are going to be given functions, and then based on the location of the number, we have to determine what's happening with our parent function. All right, so this -3, okay, it's in the k position. It is outside of my parentheses, so it affects the y. So the y goes up, down, and this is going to be negative, so it's going to go down 3. All right, 6. 6 is at h. 6 is inside with the x, so therefore it affects the x. So when we affect the x, we go right, left. Okay, and our natural inclination is to go right because it's a positive 6. But remember, our negative sign here tells us we go opposite. Okay, so instead of going to the right, we will do the opposite and go left. 6. So our vertex, and that was at 0, 0. We can go left 6, 1, 2, 3, 4, 5, 6, and then down 3, 1, 2, 3. Or if you wanted to go down 3, 1, 2, 3, and to the left 6, 1, 2, 3, 4, 5, 6, you end up in the exact same spot. Okay. Now we can put in a couple more dots. So let's see. That one matches. Now let's put in this one. We cannot place this dot here because, well, it's off the graph, but we can place this one. Okay, so over one more, and that's 1, 2, 3, 4, right? Yeah. Okay, so now we can draw our parabola. All right, some of it's off the graph, but we just shifted the entire parabola over 6 and down 3. All right, so these next two we are not going to graph. We are just going to talk about how the graph would move. Okay, so we have an h. It is inside with my x, so it is right, left. All right, and normally we would think to go to the left because it's a negative, but remember negative is opposite of. When we affect the x, we're going opposite of. So the opposite of left is right. And how many? 4. Okay. Now this is outside of my parentheses, so we are doing A. Okay. So it's outside the parentheses. It is vertical. All right. So it is vertical. And we are a fraction less than 1. Okay, so it is a compress. Okay. And now this one here. Okay. Plus 5 is outside of my parentheses. Since plus 5 is outside my parentheses, I have a K. Since it's outside my parentheses, it affects the y, not the x. So we talk about up, down. Well, this is plus 5, so we are going up 5. Now, if we'll notice, our 1/3 is inside our parentheses next to our x. Inside our parentheses next to our x is our b. All right? So it is affecting our x. So instead of vertical, we are horizontal. Okay, horizontal. And because it affects our x, we are opposite of. So it is a fraction less than 1, but this time we are a horizontal stretch. Okay. So remember, each of the numbers tells you something different, and it's based off where it is located. If it's inside the parentheses or outside the parentheses, how it affects the graph itself. Now, the other thing you might see, okay, just throwing it out there to put in the back of your mind, if you have a function, all right, and your x is in parentheses, you are going to treat this like an h and go the opposite, so you would go to the right 3. Treat it just like the h. The parentheses are in the exponent position, but you would still treat this like the h. And then if there is a plus 4 afterwards, all right, this is outside, behind. There is a plus sign in front. So you would treat this like the k and go up 4. All right, so you are simply telling me how we would move based on your equation. All right, so like I said, a lot of people were able to do the assignments. They had like 30 minutes, 25 to 30 minutes in class, depending on the class. And a lot of people were able to do our assignment very easily. And then we'll have another assignment working on some different translations tomorrow, but all from these notes. All right, so good luck.